Very good afternoon, everyone. I am Devashish Das from University of Kolkata, India. Our co-authors are Dr. Saurabh Banerjee from India, Dr. Pushpita Chatterjee from USA, Professor Uttam Ghosh from USA, Professor Utpal বিশ্বাস from India, and Professor Atik Mansur from UAE. Our paper title is Security, Trust and Privacy Management Framework in Cyber Physical System using Blockchain. Nowadays, cyber physical systems are growing in the evolution of interaction with the physical world components like physical machines and another which are to be connected with the computational device, and CPS can control and manage several applications in the several domains to the physical world. Cyber physical systems can integrate sensing, computation, control management, and networking with the physical objects and infrastructure that are connected with the computing devices. CPS has the capability to impact technology in several domains for several industries and organizations, and it allow us to imagine, create, develop and design smart systems in the fields that can beneficial for industries and other communities. Blockchain can enhance the performance of CPS using peer-to-peer communication mechanism, where each and every component of the smart CPS can communicate securely. It can also increase the performance of cyber physical systems, security, privacy and trust management within the cyber physical systems components. CPS is a architectural paradigm that combined with several communication technologies and sensing device that collected data from the physical worlds or physical systems. It can combine actual system or objects that will build in computer resources and data storage. All the information are stored in the data storage and can communicate with the cyber physical systems other components. Blockchain ensures information security shared over the CPS network, and thus we proposed a blockchain enabled CPS systems. The challenges in CPS are security, consistency, privacy, storage management, scalability and others, lack of infrastructure, etc. This diagram shows the challenges in CPS in several domains like smart vehicles, smart grids, healthcare systems and industrial control systems. The blockchain-enabled CPS can used for addressing these challenges, and it provides distributed control systems, automated authentication, security, privacy and trust management within the cyber physical system components. Figure 4 shows the benefits of blockchain-enabled CPS and its applications areas in several domains. The proposed framework consists information systems, controller and verifier, middleware components and physical systems. Information system just stored the data. In this proposed work we used interplanetary file system IPFS servers, and that can store data collected from the sensor devices. Therefore, controller and verifier verify the identity of sensor devices as well as authenticate the data accuracy and recent data validity coming from the sensor devices. Sensor collects information from physical system and actuators act based on the received data from the controller and act to the physical systems. Physical systems are embedded products, services like devices, vehicle devices, instrument and other physical machines. This is the proposed blockchain-enabled CPS framework. Here physical systems transfer the data to the blockchain network and therefore controller compute the data collecting for authentication. Controller collect from data from the blockchain and therefore verification process is done using smart contract, and therefore if data is valid then controller send to the data actuator and therefore physical system act based on the actuators receiving signals. Blockchain-enabled CPS framework implementation methods are presented in this way. In the first way, data collection, therefore data verification, data storing and accessing mechanism, and data control management. First of all, sensor device collect information from the physical environment and therefore smart contracts allow to store only the verified data to the IPFS server, and as well as smart contract store the data hash to the blockchain, and using this hash data controller can collect information from the smart contract and verify the data using blockchain technology. Each authenticated node like the controller and actuator can access data from the IPFS server. Data control management is present here. The controller controls the data automatically using smart contracts, like data verification, like recent timestamp of data stored in the sensor device. Using this timestamp, controller can identify and validate the data that is stored in recently in the sensor devices. This is the interaction between CPS components and blockchain technology. First of all, physical systems, sensor devices collects data from the physical systems and therefore smart contract checks that sensor identity, like which devices, which data collected from the which sensor devices, and after verification of identity, smart contracts check data validity, that is currently stored on the sensor device or not. If yes, then this data stored in the IPFS server. Therefore, controller collect the stored data from the IPFS server and send the signal to the actuator, and therefore actuator sends the signal to the physical system to act based on the received data that is collected from the previously sensor devices, and finally all the transactions are stored in the blockchain and only verified transactions are stored in the blockchain. So in this way the proposed framework is worked. Benefits of the proposed framework. The proposed framework can be applied in healthcare management systems to enhance the performance of verification of devices, validation of data, and sharing the real-time medical information. And this can be applied also smart transportation systems where vehicle devices can act based on the verified and validated data using the proposed framework. Vehicles can only send the verified data and compute the verified data based on the authentication mechanism. Energy trading management in the smart grid can enhance the performance of real-time data sharing and access mechanism that is the real-time data using the proposed systems. So the industrial control system also controls the physical system or machines by deploying the proposed framework securely. Blockchain provides the distributed cyber physical system framework with network transparency and data security. Whenever the sensor device collect data, controller only collect and store verified data. If this is not happened, therefore smart contract blacklist the sensor nodes which are act maliciously, and the proposed system can be applied in various domains like smart transportation, healthcare management systems, smart grids, and industrial control systems. The proposed framework can also provide a secure storage management for the data storing and um, secure communication purpose in the various components of with the various components of cyber physical systems. And this is the very transparent framework that can controller in the cyber physical system can control the overall system, and his controller know every nodes in the connected blockchain network like actuators, sensor, etc. In future, we want to focus on integrating machine learning or AI into the with blockchain to CPS for obtaining reliable and efficient application with several classification algorithm, using several classification algorithm to detect classified data from the sensor collected from the sensor device, and based on this collected data, controller can easily classify the data before authentication of data, and it can we can get secure, trusted, and privacy preserving application in the future generation CPS using blockchain and 5G technology. And this is combination of a wireless networking with the cyber physical systems, so that can be network delay or communication delay can be reduced using the in the future work plan. These are some reference used in the proposed work and some literature reviews. Thank you so much everyone for listening me carefully, patiently. Thank you.